Welcome back. Today we're going to be talking about negative exponents. Our content objective is students will be able to simplify expressions with exponents that are positive, negative, and zero. Our language objective is students will be able to explain in words the process of simplifying exponent problems. Why am I learning this? Well, it's important for real-world problems like representing the size of something very small, such as the diameter of a white blood cell. First, let's go over some background knowledge. We talked about what a base is. The base is a digit that is repeating. Okay, we talked about the exponent. The exponent will tell you how many times to repeat the base. Okay, what typically we do is we write things as an expanded product and then evaluate. Writing things as an expanded product really helps us visualize to see how many of the base we are left with or how we can simplify it if we're asked to evaluate. We know exponential form, it basically is a number with an exponent. Expanded product is when we write it all out. What does 2 to the 5th mean? We write out, okay, 2 is being repeatedly multiplied a total of 5 times. And evaluate means you're simplifying all the numbers that you possibly can. So in this case, we multiplied it all out and got 32. Now, one thing we have to really make sure we remember is the difference between the special exponents problem, which in this case, we need to make sure we read it correctly. Here, it's the opposite of 4 cubed. The opposite of 6 squared. Unlike this, when there's parentheses surrounding the base, this would be considered negative 4 squared. Okay, so here, quick reminder, we would read this as the opposite of 5 squared, and this one we would read as negative 8 squared. So there is a difference. Okay, this is a negative base, this is not a negative base. And again, we always expand them out, and then if need be, we will multiply to evaluate if the instructions tell us to. Now, we also talked about this in the previous lesson. We went over exponents and what it means when something is raised to the 0 power. And following the pattern, we figured out anything raised to the 0 power is 1. Okay? Now, another thing to keep in mind is be reminded that positive exponents indicate repeated multiplication. Okay, so why am I telling you this? Well, what happens when we have a negative exponent? Okay, well, negative exponents actually represent the opposite. Negative exponent represents repeated division. So let me quickly show you. First, we have a positive exponent. 5 squared means 5 times 5. But 5 to the negative second power is repeated division. So what ends up happening is we're doing 1 divided by 5 times 5. Okay, so again, let me give you some more examples. And I'm wanting you to look for a pattern that you notice. Here, 5 squared is 25, but here, 5 to the negative second is 1 over 25. Okay, moving on. Negative 3 to the second power. Real quick, that's negative 3 times negative 3. But negative 3 to the negative second power is going to be 1 divided by negative 3 times negative 3. So here when we multiply it, negative times a negative gives us a positive 9. But over here, we're going to get 1 over 9. So, hopefully you're noticing a pattern here. I'm going to continue. Here, notice I'm going to read this as the opposite of 2 cubed. So I'm going to put the negative on the outside and then put 2 repeated 3 times. Here I have the opposite of 2 to the negative third. Here you're going to notice it's the opposite of 1 over, or 1 divided by 2 times 2 times 2. So here the answer is going to be negative 8, but over here the answer is negative 1/8. So quick reminder, positive exponents represent repeated multiplication, but negative exponent represents repeated division. Okay, so notice we're starting with 1 and we're dividing. Okay, let's see, 3 halves cubed is going to be 3 halves repeated 3 times. But 3 halves to the negative third power is 2/3 repeated 3 times. So that's the difference between 27/8 and 8/27. So by this point, hopefully you're recognizing a pattern. So what I'd like you to do now is pause the video and try numbers 1 through 6 on your own. Okay, so let's see how we did. Hopefully for number 1, you got 2 times 2 times 2, which is 8. For number 2, you should have gotten 1 over 2 times 2 times 2, which is 1/8. Number 3, 6 squared is 6 times 6, which is 36. Number 4, 6 to the negative second is going to be 1 over 6 times 6, which is 136. Number 5, 3 to the fourth is going to be 3 times 3 times 3 times 3, which is 81. But 3 to the negative fourth is going to be 1 over 3 times 3 times 3 times 3, which is 1 over 81. Okay, so now what I'm going to do is I'm going to help you out and then ask you to help me. For number 7 here, we're going to repeat the 1/2 a total of 3 times. So that's going to be 1/2 repeated 3 times, and then when I simplify it, I'm going to be left with 1/8. Knowing that, can you now tell me the answer to number 8, which is asking the same thing, but instead of being raised to the third power, they're asking us to raise it to the negative third power. Given my answer, what would you say number 8 is? Hopefully your response is 8. Whoops, got ahead of myself. For number 9, we're going to repeat the same process here. We're going to do 2/5 repeated 2 times, which it looks like this. I'm going to simplify that. 2 times 2 is 4. 5 times 5 is 25. So I'm left with 4 over 25. Knowing this, I want you to go ahead and figure out what 2/5 to the negative second power is. So it's the same thing, except instead of asking for raising it to positive 2, we're going to raise it to a negative 2. So hopefully by this point, it's clear that a negative exponent represents reciprocals to the same situation as a positive exponent. So here, for a positive exponent, it's 1/8. So if they gave me a negative exponent, it was the reciprocal. So if I flip over 1/8, it becomes 8. Same thing here. Same idea, but a negative exponent. So I'm going to take the reciprocal of 4 over 25, which leaves me with 25/4. Now, recognizing those patterns definitely could come helpful, but the key thing that I want you to get from this is to understand that positive exponents represent repeated multiplication, and on the other hand, negative exponents means repeated division. So here, since there's a negative exponent, that means instead of repeatedly multiplying, you're going to be repeatedly dividing. So this means 1 divided by, and you're divided by 3 a total of 2 times, which gives you 1/9. Same thing here. This is a negative exponent, so instead of doing repeated multiplication, you're going to do repeated division of a negative 2. So I'm going to do 1 divided by negative 2 a total of 3 times. So that's going to leave me with 1 in the numerator, and for the denominator, well, negative times a negative is a positive, times a negative is a negative. 2 times 2 is 4 times 2 is 8. Now some of you are going to ask, okay, what if you wrote it like this? Would that work? Yes. Or maybe you wrote it like this. Does this work as well? Absolutely. All of these are acceptable answers. Okay? Now moving on to number 13. So again, because of this negative exponent, instead of doing repeated multiplication, I'm going to do repeated division. Now be very careful. This one I'm only repeating the 5. Why? Because there's no parentheses telling me that the base is negative. Here it clearly told me that the base was negative, but here it does not. So we're going to keep this negative, or we would actually read it as the opposite, on the outside. And then I'm going to go ahead and, since it's negative, I'm going to repeatedly divide. So it's 1 over 5 repeated 3 times. So here I'm going to simplify a negative times, this is all positive, it's going to be a negative 1 over 5 times 5 is 25, times 5 is 125. Okay, as for number 14, now one thing I do want to address before we get started is to please, a lot of students want to distribute this negative and make it a positive 4. That would be incorrect. Technically, what you will have to do first is exponents, because according to the order of operations, please excuse my dear Aunt Sally, that's what we used to memorize the order. We must work with parentheses before we do the exponent. So here, within the parentheses, you can't simplify it, then you have to do exponents. So since it's a negative exponent, we're going to do repeatedly divide a negative 4, a total of 2 times. So notice this negative is going to remain on the outside. So here I'm going to start with 1 and divide by a negative 4 a total of 2 times. So here I'm going to be left with, let's see, a negative times a negative is a positive times a negative will be negative. 1 is my remainder, my numerator, and my denominator will be a 16. So there are our answers. Now, real quick, let's review what power to power is, okay? Power to power is having one power raised to yet another power. So here, ask yourself, what's being squared? You'd say 5 cubed. So I'm going to go ahead and write 5 cubed, a total of 2 times. So here's once, and here's my second set. 5 cubed, 5 cubed. Now, to simplify this, I'm just going to go ahead and say that there is 6 of them, so I'm going to say that's 5 to the 6th power. Now, the other option that I showed you yesterday was here where I said, okay, what's being squared? 5 cubed, right? All of this. So I'm going to go ahead and write 5 cubed 2 times. And then at this point, you have to recognize what is the base, what's going to be repeated over and over. And hopefully you can recognize that it's going to be a 5. I know it can get tedious to write these numbers over and over. In fact, when the numbers get larger, it does get very tiresome. So what I'm going to allow you to do is imagine. Here, if you actually did write them out, how many would you write? Well, you would write 3 of them here and another 3 here, which would give you a total of 6. Okay? So that's one way of doing it. However, if you're struggling, if you're working on my open math and you're finding yourself missing the problem often, you should stick with writing everything out. Do not go here. However, if you feel comfortable with this and you have been successful and you want to upgrade to this, I can totally understand as well. Okay, moving on. So now it says here, write each of the following in simplest exponential form using positive exponents. Keyword, we have to use positive exponents. So first, let's remind ourselves the order of operations. It's please excuse my dear Aunt Sally. Parentheses comes first. Is there anything within the parentheses I can simplify? Yes, within the parentheses, I can simplify 2 to the negative third. Because of this negative exponent, I am supposed to turn into a positive. So how do I do that? Well, negative exponents represent repeated division. So I'm going to go ahead and change this to repeated division. I'm going to start with 1 and repeatedly divide by 2 a total of 3 times. So 1, 2, 3. Now be careful. Notice it's still being squared. So I'm going to go ahead and square this entire thing. Now what would that look like? Well, I'm going to go ahead and repeat this entire base a total of 2 times. So here's once. And then here's one more to give us a total of 2. So I'm going to say my final answer is 1 over 2 to the, well, there's 1, 2, 3, 4, 5, 6. 6 of them. Okay, so let's practice with number 16 as well. First, I'm going to start with parentheses. Is there anything I can simplify inside? Yes, because it's a negative 2, that does mean repeated division. So instead of multiplying repeatedly, I'm going to divide. So we're going to start with 1 divided by 3, a total of 2 times. But, whoops, I wrote a 2 on accident. A total of 2 times. Now, once again, still note that it is being raised to a negative third power. So I'm going to go ahead and raise that to the negative third power. Well, guess what? Because it's a negative exponent, I'm going to do repeated division. Now, I'll be honest, doing repeated division here is going to get messy. So if you can recall from the beginning of this lesson, we did recognize that negative exponents, essentially what happens is we take the reciprocal of it. So let's do that instead. We're going to go ahead and flip this over to 3 times 3 over 1, and we're going to go ahead and repeat that a total of 3 times. So here's the second set, and here is my third set. That's going to leave me with 3 to the 1, 2, 3, 4, 5, 6 over 1, which just simplifies to 3 to the 6th power. Okay, so it's good to understand both, okay, number 1 it's important to understand that negative exponents represent repeated division. And second, it's also important to recognize that basically negative exponents, what ends up happening is you take the reciprocal of the positive exponents. So keep that in mind. Okay, we're going to go ahead and move on to the next. So let's do a couple more before I have you try some on your own. Okay, so looking in the parentheses, 5 cubed is okay. It's already positive. Now looking on the outside, since this is a negative exponent, we're going to go ahead and repeatedly divide by 5 cubed. So we're going to start with 1 and divide by 5 cubed, a total of 2 times. So at this stage, I'm going to say my numerator is 1, and my denominator, well, first, the base is a 5, and it's going to be repeated 3 here, another 3 here, which gives us a total of 6. So there is my final answer. And what about number 18? Well, here we can simplify the inside. Since it's a negative exponent, we're going to do repeated division. So we're going to change that to 1 and divide by 4, a total of 1 time. But note again that it's still being raised to the negative third power, so let's do that. Okay, so here what we're going to do is then recognize, okay, it's a negative exponent, so I'm going to do repeated division, a total of 3 times. So in the previous example, I did show you that you could simply just take the reciprocal. However, if you're wondering, okay, how should it work? The other way, by repeated division, well, here's how it would go. You would start by 1 and divide by 1/4, a total of 3 times. Well, guess what? That's going to leave us with 1 over a 1/4 repeated 3 times. But we know we shouldn't be leaving our answers like this. This is a complex fraction. So I'm going to do some side work here. There's not a lot of space, pretend there is. And simplify this. This means 1 divided by 1/4 cubed. So with division, what we do is we multiply by the reciprocal. So here I'm changing to multiplication. I'm going to take the reciprocal, and it's still cubed. So here this means 1 times, technically 4 over 1 is just 4 cubed, which ends up being just 4 cubed. But now going back, could you again just have taken the reciprocal because it's a negative exponent? Absolutely. By taking the reciprocal, you should have gotten 4 over 1 cubed, which is still once again just 4 cubed. So now it is your turn. I'd like you to go ahead and pause the video and try numbers 19 all the way to 24 on your own. Now let's see how well you did. So here, hopefully you had 1 over 3 to the 6 raised to the 4th power. If you repeat this 4 times, you should end up with 1 over 3 to the 24th power. Here, since this is a negative exponent, that would turn into 1 over 4 to the 7th. And you're going to repeat this 3 times, which is going to leave you with 1 over 4 to the 21st. Here, be very careful. This is not a negative base. This is the opposite of 2 cubed, raised to the negative 5th power. So what's going to happen here is you're going to repeatedly divide by 2 to the 3rd power, a total of 5 times, keeping that negative on the outside. So let me show you. That's going to be 1 divided by 2 cubed 5 times. So once, twice, 3 times, 4 times, 5 times. So that is going to leave me with a negative answer. So it's negative 1 over 2 to the 3 here, 6, 9, 12, 15. So it's going to be a negative 1 over 2 to the 15th power. Now here, since they're both positive exponents, which are great, we're going to go ahead and repeat negative 5 to the 5th power a total of 5 times. If you do that, you should end up with negative 5 raised to the 25th power. Now you need to be very careful. A lot of students are neglecting the parentheses, okay? And it's important that you remember to do that. So at this point, let's just go ahead and go over answers. Number 23, it will end up being 3 to the 12th power. If you write them all out, you're going to find that the negatives will cancel each other out completely, so just be positive. For number 24, you should end up with 1 over 2 to the 28th power. At this point, I would like you to go ahead and pause the video and practice numbers 25 through 27 simply by evaluating the expression. Okay, so let's check out our answers. Here, what is being squared? It is a -6. So we're going to keep this negative on the outside and just write at that negative and repeat the -6 2 times. Now to evaluate, a negative times a negative is a positive times a negative is a negative. So here we would end up with -36. Now here, since it's a negative exponent, we're going to go ahead and do repeated division. So it's going to be 1 over -2 repeated a total of 4 times. Now let's take care of the signs. First, a negative times a negative is a positive times a negative is a negative, and a negative times a negative is a positive. So that's going to leave me with 1 over a +16. Now once again here, this is a negative exponent, so I'm going to do repeated division of this -2. But let's make sure to keep this opposite symbol on the outside. So here we kept the opposite symbol on the outside and did 1 and divided by -2 repeatedly a total of 4 times. Here a negative times a negative is a positive. Here a negative times a negative is a positive. So positive times a positive times a negative is going to leave me with a -1 over 16. So guess what? That's going to conclude the lesson for today. Thank you so much for tuning in,